Okay, so you'll recall in our previous video and our previous lesson, which was at the end of last term, we looked at the equation, or we looked at drawing graphs of circles, okay, and we established via our understanding of transformations that the general equation for a circle with its centre with coordinates of hk and a radius of r is given by this, okay. And so what we want to do in this video is just continue to make use of that, but also look at examples where we might not be given the equation in that form, and how do we go about getting the equation back to that form. Okay, so let's just deal with some relatively simple questions with our understanding of this equation of a circle. And that is, in example 1, to state the centre and radius of the circle with equation x plus 5 all squared plus y minus 3 all squared equals 12. Okay, so this is definitely the format of the equation of a circle that we're seeing here. So we've got plus 5 as h and minus 3 as k. Now remember, the centre is at hk, so if it was minus 2 minus 3, the centre would be at 2, 3. But we have got, or let's say if it was minus 5, just to keep it consistent, minus 3, the centre would be at 5, 3, but we've got plus 5. And so that means we want to be able to think about this as being minus 5, okay? And so that means the centre is at negative 5, 3, okay? So the centre is at negative 5, 3. And the radius is to do with this 12. It's the square root of that though, because that's the radius squared. And the radius is the square root of 12, which is asserted not in simplest form. Root 12, 12 is 4 times 3, so that's root 4 times root 3, and so it is 2 root 3 in simplest form, the radius. Okay, example 2, give the rule for a circle with a radius of 5 and a centre at 3, negative 7. Okay, so centre at 3, negative 7 means that we'll have x minus 3 and y plus 7 for the centre at negative 7, and then equals 5 squared, so that'll be 25. Example 3, give the rule for a circle with a radius of 2 root 3 and the centre at negative 1, 1. Okay, centre at negative 1, so it'll be negative 1, 1, sorry, so it'll be x minus minus 1, so x plus 1 all squared, and then be y minus 1 all squared, equals 2 root 3 all squared. Okay, so let's maybe just simplify that over here. So 2 root 3 all squared is 2 squared times root 3 squared, so that is 4 times 3, and so that is 12. Oh, I actually gave you the same one you'd had here, so it was nice and easy, but you know, being able to work with the surds in both directions is important. Okay, example 4, find the rule for the graph pictured. Okay, so to find the rule for a circle, we're going to need to know the centre, which we've got, okay, and we're going to need to know the radius, which we don't have, but we do have a point on the circumference, and so therefore the distance between these 2 points is going to give us the radius, okay. So we know the distance between 2 points, if we remember how to do that, it's the square root of, and I'm going to show you how to do it if you don't remember how to do that. Remember, it's the difference between the x coordinates, so negative 1 minus negative 3 all squared, plus the difference between the y coordinates, 2 minus 0 all squared. So that is the square root of negative 1 minus minus 3 is negative 1 plus 3, so that is 2 squared plus this is also 2 squared. So it's the square root of 4 plus 4, which is root 8, and so that is 2 root 2. But interestingly, if you know, in fact it's quite helpful to stop here that r is root 8, that means that r squared is 8, which is helpful because we need r squared in the equation. So the equation is going to be, so we know that the centre is at negative 1, 2. And so therefore the equation is going to be x minus minus 1, so x plus 1 all squared, plus y minus 2 all squared equals r squared, which is 8. Just a quick, if you don't remember the formula for distance between 2 points, remember the distance between 2 points is just Pythagoras. So just draw yourself a triangle and use Pythagoras. It's exactly the same thing. Okay, so this distance here is 2, this distance here is 2. So r squared equals 2 plus 2, which means r is the square root of, sorry, not 2 plus 2, 2 squared plus 2 squared, which is r is the square root of 2 squared plus 2 squared. And oh, look, that's where we got to with our distance between 2 points formula. So that's exactly the distance between 2 points, the formula for distance between 2 points is Pythagoras' theorem. So draw a diagram and do Pythagoras if you don't remember the formula, okay? So it'd be root 8, which is 2 root 2. Either way. So we've got our equation. Okay, the next thing we want to look at in this section is if we imagine if we take an equation of a circle, so I've just picked one here, so x plus 1 all squared plus y minus 3 all squared plus 5, sorry, equals 5. We know that that's an equation of a circle with its centre at negative 1, 3, and a radius of root 5. However, it's possible to expand this equation and therefore write it in a different form. So if we expand out the perfect square of x plus 1 all squared, we know that that's x squared plus 2x plus 1. If we expand out the perfect square of y minus 3 all squared, we know that that's y squared minus 6y plus 9. And we collect together all our like terms and perhaps subtract the 5. We can end up with something that looks completely different. But these are the same thing. Okay? And so what we need to be able to do is if we want to be able to find the centre and the radius, we really need to get it back into this form. So we want to think about how we're going to reverse this process. And in fact, remember, in expanding that equation out, we expanded out the perfect squares. So we want to complete the square to work backwards. Okay. And so this is where another one of those examples where our quadratic skills come up in all sorts of other areas, and we must continue to work on improving and refining our skills involving quadratics because they appear out of nowhere in other places. Okay, so we want to use completing the square to write the equation x squared plus y squared, I'm looking at example 4 here, x squared plus y squared minus 4x plus 14y plus 52 equals 0 into the standard form for an equation of a circle so that we can then hence state the coordinates of the centre and the radius. Okay, so what you want to think about when you want to complete the square is you want to worry about getting the x terms together and sort of trying to complete the square with those, and the y terms together and trying to complete the square with those. And for now, the negative 52 I'm going to pop on the other side, and I'm just going to worry about that later. Okay, so x squared minus 4x, leave room to complete the square there, plus y squared plus 14y, leave room to complete the square there, and that's going to be equal to negative 52. Okay, so completing the square, we know we halve and square the coefficient of x, so half of negative 4 is negative 2, and negative 2 squared is 4. So we're going to add negative 4 here. That is now a perfect square. Now remember, we can't just add in negative 4 because we feel like it, so we're also going to subtract negative 4. Now the other way you can do it here, if you prefer, is rather than taking away negative 4 here, we could balance out the fact that we've added in 4 here by adding in 4 on the other side. Either way, you'll get to the same place, whatever you feel comfortable with, as long as you are somehow cancelling out the fact that you have added on a plus 4. So whether that's about immediately subtracting it there, or whether that's about adding on 4 on the right-hand side, so you actually haven't changed the equation, you've added 4 to both sides. It's up to you, however you prefer to do that, okay? All right, then we're going to focus on the y terms. We want to halve and square 14. Half of 14 is 7, and 7 squared is 49. Okay, so that's now a perfect square there. Now again, I can take away 49 here to balance the fact I've just randomly added in 49, or instead I can add it on to the right-hand side. So I've added 49 to both sides of the equation, and hence I haven't actually changed the equation. Okay, so now we've got two perfect squares. It is x minus 2 all squared plus the y terms, that perfect square, that is y plus 7 all squared. So remember, it's half of the 14 to work out what goes in here, half of the negative 2 to work out what goes in the x bracket. And then on the right-hand side, we've got negative 52 plus 4 and plus 49. 4 plus 49 is 53, and so therefore negative 52 plus 53 is 1. And so therefore we have a circle with its centre at 2, negative 7, and a radius, try that again, and a radius of the square root of 1, which is 1. Okay, let's do that again. State the centre and radius of the circle with equation x squared plus y squared plus 6x minus 8y equals plus 18 equals 0. So again, let's just reorganise it slightly. Let's focus on the x terms together. So x squared plus 6x, complete the square there. Then we're going to have plus y squared minus 8y, let's complete the square there, and that's going to be equal to negative 18. Alright, so let's focus on the x terms. So halving and squaring 6, half of 6 is 9, half of 6 is 3, and 3 squared is 9. Okay, so that's my perfect square. I've added in 9, so I'm also going to add 9 onto the right hand side to balance that out. So I haven't actually changed the equation. And then y squared minus 8y, so we want to halve and square negative 8. Half of negative 8 is negative 4, and negative 4 squared is positive 16. So there's my perfect square there. Now I can't just add in 16 and expect it still to be the same equation. So if I add 16 onto the right hand side, I've done the same thing to both sides, so it's the same equation. Okay, perfect squares. So x squared plus 6x plus 9. Half of the 6 is x plus 3 all squared. And then y squared minus 8y plus 16, half of negative 8 means it's y minus 4 all squared is a perfect square, equal to, okay, negative 18 plus 9 plus 16. Negative 18 plus 16 is negative 2 plus 9 is 7. Okay, and so therefore we have a centre at negative 3, 4 and a radius of root 7. Okay, so we've already seen how to complete the square with our CAS, so menu 3, 5 is completing the square. However, and one of the reasons you might remember when we did that earlier on, you have to put comma x, which just seems a bit unnecessary, but that's because we can complete the square when we have more than one variable, like what we have here. We have both x and y. And so actually, if we want to complete the square for this, we simply we can simply convert this into our standard kind of circle form by using the CAS to complete the square. And you can actually put the full equation in and comma x, comma y to get it to complete the square for the x variables and for the y variables, and to therefore write the equation in our standard circle form. So let me just show you what I mean by that. So, menu 3, 5, so complete the square. I'm just going to put in this equation as it appears. So x squared plus y squared, x squared, it looks like x is defined as something. My apologies, I was doing something earlier. Let me just clear some variables. Menu 1, 4. Okay, so menu 3, 5, x squared plus y squared plus 2x minus 8y plus 9 is equal to 0. And we want to complete the square for both x and y, so comma x, comma y, and it will immediately tell us that this equation can be rewritten as x plus 1 all squared plus y minus 4 all squared equals 8. And so therefore, the centre is at negative 1, 4, and the radius length is the square root of 8, which is 2 root 2 in simplest form. Okay, so the work for today is listed here. You'll notice that question 12a, I've asked you to do the left-hand side of that question by hand, so doing the completing the square by hand, and the right-hand side, practice using your CAS to do those ones. Okay, so that is the work for today.